You think you know the difference between sound and light. Sound is what you hear. Light is what you see. Sound travels through air. Light travels through space. Sound is slow. Light is fast. Simple. Different senses. Different phenomena. Different physics. Wrong. Here's a question. What's moving when a sound wave passes through the room? You say air molecules. Good. The air vibrates. The vibrations travel. That's sound. Now, here's the next question. What's moving when a light wave passes through the room? You hesitate. You want to say photons, or electromagnetic fields, or something about waves, but you don't really know, do you? You've just heard words. And here's what's going to break your brain. The fundamental difference between sound and light isn't about what sense detects them. It's not about speed. It's not about whether they travel through air or vacuum. The fundamental difference is this. Sound requires matter. Light does not. Sound is matter doing something. Light is something matter does. Let me show you why this distinction shatters everything you think you understand about waves, about energy, about the nature of reality itself. You're sitting in a quiet room. Someone across the room claps their hands. A fraction of a second later, you hear it. What just happened? Walk me through it. Actually explain it. Not just the sound traveled through the air. Tell me the mechanism. What physically moved from their hands to your ears? You can't, can you? You know the sound traveled, but you don't know what that means. You think something went from there to here, some kind of wave or vibration. But what is the wave made of? What's vibrating? Here's what actually happened. When the hands clapped, they compressed the air between them. They squeezed air molecules together. Those compressed molecules pushed on the molecules next to them, compressing them. Those molecules pushed on the next layer, and the next. A wave of compression traveled outward through the air. Not the molecules themselves traveling, the compression traveling. The molecules just wiggled back and forth. The disturbance propagated. Think of it like a line of people standing shoulder to shoulder. Someone pushes the first person. That person bumps into the next person, who bumps into the next. A push travels down the line, but the people don't travel. They just transfer the push. Each person moves forward slightly, then back to their original position. The push moves, the people don't. Sound is like that. Air molecules don't travel from the clap to your ear. They oscillate. They move back and forth. They bump into their neighbors. The neighbors bump into their neighbors. The pattern of compression and rarefaction, of high pressure and low pressure, propagates through the air at about 343 meters per second. That propagating pressure wave is sound. Now let me ask about light. The sun is 150 million kilometers away. Sunlight reaches Earth in about 8 minutes. What traveled through those 150 million kilometers of space? What moved from the sun to your eyes? You want to say photons, particles of light. But particles of what? What are they made of? Or you want to say electromagnetic waves. But what's waving? Space is empty. There's nothing between the sun and Earth except vacuum. No air, no molecules, nothing. So what's the light made of? Here's the truth that's going to destroy your intuition. Light isn't made of anything. Light is a disturbance in a field, the electromagnetic field. And the field isn't a substance. The field is a property of space itself. The field exists everywhere, always, even in perfect vacuum. And when the field oscillates, when its value at each point changes rhythmically, that oscillation propagates. That's light. Sound needs molecules to exist. No air, no sound. Light needs no molecules. Light propagates through perfect vacuum. In fact, light travels better through vacuum than through anything else. Matter slows light down. Vacuum is light's natural habitat. This is the fundamental difference. Sound is a mechanical wave. It's matter pushing on matter. Light is an electromagnetic wave. It's a field propagating through space. They're not just different phenomena. They're different categories of phenomena. Let me make this concrete. Let's do an experiment you can imagine. Take a bell, rim it, you hear a sound. Now put the bell inside a glass jar. Pump all the air out, create a vacuum. Ring the bell again. You see the clapper hit the bell, you see it vibrate, but you hear nothing, no sound. The bell is still making vibrations, but there's no air to carry them. The compressions and rarefactions have nowhere to go. Sound requires a medium. Now do the same with light. Put a flashlight in the jar, pump out the air, turn on the flashlight. You see the light perfectly clearly. In fact, you see it better than before because there are no air molecules to scatter it. Light doesn't need air. Light doesn't need anything. Light travels through vacuum just fine. The Apollo astronauts proved this. On the moon, there's no air. When they dropped tools, the impacts made no sound, but they could see everything perfectly. Light from the sun illuminated the surface. Light reflected from objects into their eyes. They could take photographs. They could see, but they couldn't hear, because seeing uses light, which needs no medium. Hearing uses sound, which does. Now let's dig deeper. Let's ask why sound needs a medium. What is sound fundamentally? Sound is a compression wave, a pressure wave. Regions of high pressure alternating with regions of low pressure, traveling through a material. When molecules are pushed closer together, you get high pressure. When they're pulled apart, you get low pressure. The wave is the pattern of pressure variations moving through space. For this to work, you need molecules. You need things that can be compressed and rarefied. You need elastic material that can be pushed and will push back. Air works, water works, steel works. Any substance with molecules or atoms that can transfer force works. Vacuum doesn't work. There's nothing there to compress. The speed of sound depends on the medium. In air at room temperature, sound travels at 343 meters per second. In water, it's 1,480 meters per second. In steel, it's 5,960 meters per second. Why the difference? Because the speed depends on how stiff the medium is and how dense it is. Stiffer materials transmit compressions faster. Denser materials transmit them slower. The ratio of stiffness to density determines the speed. And here's something important. Sound cannot travel faster than the molecules can respond. When you compress one layer of molecules, it takes time for that compression to affect the next layer. The molecules have to bump into each other. They have to transfer momentum. There's a speed limit set by the properties of the material. Now let's talk about light. Light is not a compression wave. Light is an oscillation of fields. The electric field and the magnetic field at each point in space oscillate. The oscillation propagates. And crucially, this oscillation doesn't require any medium. The fields exist in vacuum. They are properties of space itself. When an electric field changes, it creates a magnetic field. When a magnetic field changes, it creates an electric field. This feedback loop sustains itself. The changing electric field creates a changing magnetic field, creates a changing electric field, creates a changing magnetic field. Each change propagating outward at a fixed speed. That speed is the speed of light. 299,792,458 meters per second in vacuum. And here's the key. That speed is a fundamental constant. It doesn't depend on a medium. There is no medium. The speed of light in vacuum is the maximum speed at which any information can propagate in the universe. It's not just the speed of light. It's the speed of causality. It's built into the structure of space-time itself. Sound has no such limit. Sound can be arbitrarily slow. Make the material less stiff, sound slows down. Make it very stiff, sound speeds up. But there's no fundamental speed limit for mechanical waves. They're limited only by the properties of the material they're traveling through. Light in vacuum always travels at c. Always. No matter who measures it, no matter how fast you're moving. This constancy of the speed of light is one of the most bizarre and important facts about the universe. It's the starting point for special relativity. It's why time dilates and length contracts. It's why nothing can go faster than light. Because light isn't just moving through space. Light is moving through space-time. And space-time has a structure that sets that speed. But let me show you something even stranger. Even though sound and light are fundamentally different phenomena, they obey the same wave equation. They both diffract around obstacles. They both interfere constructively and destructively. They both reflect and refract. They both show Doppler shifts. Mathematically, they're described by similar equations. This is because they're both waves. And waves, anyways, share certain mathematical properties. A water wave, a sound wave, a light wave, a wave on a string, they all satisfy the wave equation. They all show interference patterns. They all have wavelength and frequency and amplitude. But the physical mechanism is completely different. Sound is matter oscillating. Light is fields oscillating. They look similar mathematically because the mathematics of waves is universal, but physically they're not similar at all. Let me prove it. Take two sound waves, send them through the same space. They interfere. Where they're in phase, they add. Where they're out of phase, they cancel. You get regions of loud and quiet, interference pattern. Now here's the key. The two waves interact with the same air molecules. They're both compressing and rarefying the same medium. They add because they're both pushing on the same stuff. Now take two light beams, cross them. They pass right through each other. They don't bounce off. They don't deflect. They don't interact at all. Why? Because they're not made of stuff. They're field oscillations. And fields don't collide. They superpose. They add mathematically. But they don't physically interact. You can do interference with light. Shine two coherent light beams on a screen, and you get bright and dark fringes, interference pattern. But the two beams aren't bumping into each other in space. They're independently oscillating the electromagnetic field at each point. The field values add. Where they add constructively, the field is strong. You get bright light. Where they add destructively, the field is weak. You get darkness. But the two beams don't interact with each other. They interact with the field. This is a profound difference. Sound waves interact through the medium. Light waves don't interact at all. They only appear to interfere because they both contribute to the field value at each point. Now let's go even deeper. Let's ask what happens at the boundaries. What happens when sound or light encounters a surface? Sound hits a wall. Some of it reflects. Some of it is absorbed. The absorbed sound becomes heat. The molecules in the wall vibrate. That vibration is thermal energy. The sound energy converted to heat energy. Both are molecular motion. Sound is organized molecular motion, a traveling wave of compression. Heat is disorganized molecular motion, random vibrations. The transition is natural. Sound dies out as it becomes heat. Light hits a wall. Some reflects, some is absorbed. The absorbed light also becomes heat, but the mechanism is completely different. The electromagnetic wave causes electrons in the wall to oscillate. Oscillating electrons emit electromagnetic radiation, usually at lower frequencies, infrared, heat radiation. The light energy converted to thermal motion, but through electromagnetic interaction with electrons, not through mechanical collision. And here's something crucial. Sound can only travel at one speed in a given medium. Light can travel at different speeds in different materials. In vacuum, light travels at c. In water, it slows to about 0.75 c. In glass, about 0.67 c. In diamond, about 0.41 c. Why does light slow down in materials? Because the electromagnetic wave interacts with electrons in the atoms. The wave causes the electrons to oscillate. The oscillating electrons re-emit electromagnetic waves. These re-emitted waves interfere with the original wave. The result is a wave that propagates more slowly through the material. But in the gaps between atoms, in the empty space, the light is still traveling at c. It's the constant absorption and re-emission that creates the effective slower speed. Sound doesn't work like this. Sound isn't constantly absorbed and re-emitted. Sound is the medium itself moving. The speed of sound is just how fast compressions propagate through that particular material. Let me give you a thought experiment that reveals the deep strangeness. Imagine you're in a spaceship far from any star, far from any planet, floating in deep space. It's dark, it's cold, there's no air. You can't hear anything because there's nothing to carry sound. But you can see distant galaxies. Light from billions of light years away reaches your eyes. That light traveled through almost perfect vacuum for eons. No medium, nothing carrying it, just electromagnetic fields oscillating their way across the universe. If sound worked like light, you could hear explosions from across the galaxy. If light worked like sound, you'd be blind in space. But sound doesn't work like light. Sound is matter, light is not. And here's where it gets philosophical. What is reality made of? Matter and energy, you say. But light complicates that. Light is energy, electromagnetic energy, but it's not carried by matter. It exists in the fields. Fields are not matter. Fields are properties of space. So reality is made of matter, fields, and space. And matter and fields interact. Matter creates fields. Fields push on matter. But fields can exist without matter. Fields are fundamental, just as fundamental as matter. Sound teaches you about matter. how it responds to forces, how it transmits vibrations, how molecules interact. Light teaches you about fields, how they propagate, how they carry energy, how space itself has structure. You experience both every day. You hear sounds, you see light, but until you understand the mechanism, until you grasp that one requires molecules bumping and the other requires fields oscillating, you don't really understand what you're experiencing. Now let me connect this to something bigger. Let me show you how this distinction reveals the structure of physics. There are 4 fundamental forces in nature: gravity, electromagnetism, strong nuclear, weak nuclear. 3 of these forces are mediated by fields and field particles. Electromagnetism is mediated by photons, oscillations of the electromagnetic field. The strong force is mediated by gluons, oscillations of the gluon field. The weak force is mediated by W and Z bosons, oscillations of the weak field. These are quantum fields. They exist everywhere. They carry forces. They propagate through vacuum. Gravity is weird. We don't have a complete quantum theory of gravity yet, but we know gravity warps space-time. It's not carried by a medium. It's a property of space-time geometry itself. Sound is not a fundamental force. Sound is an emergent phenomenon. It's what happens when you have lots of molecules interacting electromagnetically. The electromagnetic force between molecules allows them to push on each other. That pushing can propagate as waves. Sound emerges from electromagnetism plus matter. Light is fundamental. Electromagnetism is one of the 4 forces. Photons are real quantum particles. The electromagnetic field is a fundamental field. Light doesn't emerge from anything simpler. It's part of the bedrock of reality. This is why the distinction matters. Sound is derivative, a consequence of deeper physics. Light is fundamental. It's part of the deeper physics. When you study sound, you're studying the collective behavior of matter. When you study light, you're studying a fundamental force of nature. And we can test this. We can predict properties of light from quantum electrodynamics and measure them to incredible precision. The magnetic moment of the electron, predicted by QED, matches measurement to 11 decimal places. That's the most precise prediction in all of science. We understand light at a fundamental level. Sound, we understand it too, but it's classical physics. It's Newtonian mechanics applied to continuous media. It's not fundamental. It's approximate. It breaks down at extreme scales. At very short wavelengths, you have to think about individual molecules. At very high energies, you have to consider quantum effects. Sound is an emergent classical phenomena. Light is a quantum field. So when you ask why sound is different from light, here's the complete answer. Sound is a mechanical wave requiring matter, a compression wave propagating through elastic media at speeds determined by material properties, an emergent phenomena arising from electromagnetic forces between molecules. Light is an electromagnetic wave requiring no medium, a field oscillation propagating through space at a fundamental constant speed, a quantum phenomenon mediated by photons. They're different because one is matter doing something and the other is a fundamental field oscillating. They're different categories of reality. Every time you hear a sound, you're experiencing the collective motion of trillions of molecules, all pushing on each other electromagnetically, creating a traveling wave of pressure that eventually pushes on your eardrum, causing neurons to fire, allowing you to detect the disturbance. Every time you see light, you're experiencing electromagnetic fields oscillating at hundreds of terahertz, causing electrons in your retina to absorb photons, triggering chemical reactions, sending signals to your brain. One process involves matter bouncing. The other involves fields oscillating. One is emergent. The other is fundamental. One needs a medium. The other is the medium. One teaches you about materials. The other teaches you about space itself. You thought they were similar because they're both waves, but they're not similar. They're fundamentally different. And understanding that difference means understanding the difference between emergent and fundamental phenomena, between classical and quantum physics, between matter and fields. You're not separate from these phenomena. You're made of matter that can transmit sound. You're made of electrons that emit and absorb light. You exist at the intersection of mechanical waves and electromagnetic waves. You are both the medium and the detector. That's not mysterious. That's magnificent.